We are team to see or not to see. Our mission is to see the risk and the opportunity. Our team is composed of 7. 5 of us are apprentices from 2 different cohorts. We have 1 student and 1 data analyst. Challenge summary. Our client nPlan are able to carry out risk analysis for individual projects but have no way of seeing it across the portfolio. Our challenge is to create a portfolio view and display it in an easy-to-interpret way.
For portfolio managers who struggle to compare the reports on different projects, our product combines the projects over run risk to highlight activities that have the most likelihood of causing the largest delay to the project completion. Unlike looking at 4 separate reports on 4 different scales, this dashboard presents them side by side on the same scale so that they can be compared intuitively. We also have a date slider so that we can focus on the riskiest activities on an adjustable timeline. This allows the portfolio manager to make strategic mitigation efforts in a timely manner. We can also identify future activities that are likely to overrun because similar activities have been detected as overrunning on these projects.
There were 4 CSV files and 1 NPY file for each of the project. Early exploratory data analysis indicated that some files were missing some pieces of information, and then the challenge creator supplied us with 4 new data files with the missing data. The files were anonymized, which helps to avoid any bias in interpretation and analysis. The process, that is the process of data cleaning and transformation. So we define a few functions to help us with it. The first functions that we defined was to get the file information, the information of the CSV file that we are loading. Then we define a function that helps us append each of the CSV file to a larger CSV file so that we can make a database of all the 4 projects together. And then we have a function that helps us save the CSV file, that is, helps us export the CSV file so that we can use it in Power BI. And then we have a main function where we call all of these functions and execute the data cleaning and data transformation process.
We made a risk measure by multiplying the mean forecasted duration, elapsed days, times the criticality, times the duration contribution, times the criticality float sensitivity, divided by the integer taken from the likelihood to meet planned duration. For an opportunity measure, we used mean forecasted duration of elapsed days times the forecasted savings relative duration.
Here is a quick demonstration of the dashboard we created. This first page shows the top 10 risk measures in the portfolio and how they break down for each project. The user is able to choose a date range in order to prioritize actions, as shown by this slider. More graphs will be automatically added as the portfolio expands. This second page shows the same graphs, but for opportunities rather than risks. And this final page allows the user to see what contributes most to the risk values in order to take action.
The idea behind our future developments proposal is for live information relating to completed activities in active projects to directly feed into the different distributions affecting the models. Information relating to tasks that have not yet started or completed will then be altered in real time according to changes in distributions and data models. In the proof of concept developed for this challenge, actual duration time was randomly generated given some constraints and based on planned duration time of activities. Then, the difference between planned duration time and actual duration time was used to affect change on forecast likelihood. In the dashboard created, a comparison between the original forecast likelihood and the adjusted forecast likelihood based on real-time data changes is presented. For the first judge's question on how we would go about adding further projects to the report down the line, the Python script allows us to collate additional project data files into the master files that were used within Power BI. The Power BI transformations will apply the necessary steps to transform the data. The dashboard utilizes the small multiples graph function. Additional projects will be automatically included in the graphs, with the 4 projects with the biggest risks appearing in the visual. A challenge that the final output might encounter would be a lack of space and the dashboard becoming too crowded as more projects are added.
Now with the NPY data, we first had to load and change the data frame to read and edit the file. But once that happened, the magic began. We noticed for all the completed tasks, there was an equivalent completion ratio measuring how well the task was carried out and whether it was riddled with many tasks or very few. As you can see from each of the 4 project equivalent box and whiskers plot, the projects that were riddled with the most risks were the first and third project, given that they had the highest completion ratio. Calculating the mean and median also allowed us to measure the overall breakdown of the risk trends on over 2,000 different activities. Lastly, the table below shows the 5 tasks that carried the most risk, and in fact, the top 2, although they were a part of 2 different projects, had the same exact activity ID, meaning the activity Blood Alley Unregular Signability was in fact the riskiest task among this dataset of projects.
Have you found any data quality issues, and what have you done to address them? We've found some anomalies with the start dates, planned and actuals, and the planned durations, and we mainly use the durations from the metrics file, and we use the actual dates from the activity files to filter out activities that had already completed or already started, where anything that's already completed is not relevant for looking at the future. There were some problems with activity IDs and activity names that were identical. The activity IDs, between different projects, we concatenated the first 2 characters from the file name to disambiguate those. There was a division by 0 that we resolved by rejecting those